Okay, so what I'm going to do in this video is actually show you how to perform or actually run the chi-square test of independence right on your TI calculator. So this is actually a continuation from a video I posted earlier on Blackboard. So in Blackboard, I have a video posted on this particular question, which deals with party affiliation and amount of money spent on projects in their home district. So this was a very tedious scenario, and we had to run through a whole chi-square test. What I'd like to do now is show you how you use your calculator to, number one, enter this two-way table into a matrix. There's matrix features in your calculator, and then actually the calculator will run the chi-square test. And when you run the chi-square test, what it does, it works out this whole table. Now it doesn't give you the results. It doesn't give you these individual results of the table. But what it does give you is the sum of this last column, which is the chi-square testing statistic. In addition to that, it'll give you the p-value for the hypothesis test, which you could also use to pass judgment on HO. All right, so let's show you how to set this up. So as it turns out, you've got to put this two-way table into your calculator into what's called a matrix. Now, a matrix is just a fancy word for a table. So the matrix functions in your calculator is right over here. It's, I'm using a TI-84. You can see it's above this x to the -1 key. So it says matrix right there, and it's in blue. So I have to hit my second function. If you're using a TI-83, I believe it's in yellow. So if you say second x to the -1. All right, so notice here's your matrix menu. All right, you can name your matrix. There's mathematics you could do with your matrices. What we need to do first is we need to edit a matrix. So I'm going to move my arrow over twice to the right. And let's go ahead and use A, matrix A, which is the first matrix. So I'm going to hit number 1. Now, right now, it's set to be a 1-by-1 matrix. Now, the first one is the number of rows, and the second one is the number of columns. So our matrix, if I go over here, is not 1-by-1. This matrix, now this is the original contingency table. Maybe we should look over here. It'll make it be a little more obvious. This right here is the contingency table. Just this. Remember, the row total and the column total, that is not part of the actual contingency table. That is just the totals. These are the values of the contingency table. Notice there's 2 rows and 3 columns. So I first got to tell the calculator, hey, my contingency table has 2 rows and 3 columns. So I'll type 2 and move over and type 3. Hit enter. And then there it is. Now it's set up as 2-by-3. And you can see there's 6 entries for these 6 entries right here. So what I'm going to do right now is just enter 8, 15, 22, 12, 19, and 16 into this table. All right, so let's go ahead and type those. So that'll be 8. And you just hit enter, and it pops it in there for you. 15, 22, 12. Notice when you hit enter, a carriage returns to the right, which is kind of convenient. You can type these quick. All right, so there it is. So notice matrix A, which is 2-by-3, and there they are. All right, so once that's in there, you can get out of here by hitting second, and then see that it says quit right here above the mode key. So second, quit. And all right, so now what do? Well, let's run the test. I mean, we did this test already, and we know the answer. This fails to reject. All right, so one thing I'm pretty positive of is this test, I believe, was a 1% alpha. Should refresh our memory here. Yep, there it is, 1% alpha. So the p-value, I know for a fact, since this failed to reject, I know this p-value is going to be larger than 1%. I know that. All right, but let's go ahead and run it on the calculator. It's actually pretty easy. So you go to Stat, move over to tests, which is where all your hypothesis tests are. And I'm going to hit up because it's all the way at the bottom. There's a bunch of tests in here. So if you go up, there it is. In this calculator, it's letter C, chi-square test. Don't mix that up with the one right underneath it. It says chi-square GOF test. This GOF stands for goodness of fit test. It's just a different hypothesis test that you can perform with the chi-square distribution. So I'm going to use option C here. And I believe it's option C in the TI-83 as well. All right, so I'm going to hit enter. All right, so notice what it says. Chi-square test. There's really not much to give it. All you got to tell the calculator is where your observed frequencies are. So notice it says observed. Yep, matrix A. That's where we put it. Now notice it says expected. Matrix B. Well, the expected, right now the calculator doesn't know what the expected are, but when we tell the calculator to go ahead and calculate, it's going to calculate the expected. So what this is, you're telling the calculator where you want to put, have the calculator put the expected results. Now we know the expected results. That's these little ones right here, 9, 7, 8, 16.63. We know those answers already, but the calculator will do that for you, which is kind of nice. And then you have to sit here and calculate every one of these like we did before. All right, so I'm just going to go on calculate and say enter and let it do its thing. I'm not a big fan of the draw feature. The draw feature will draw this picture. I don't really care for it much because it does a very good job with it, and it's very accurate. And sometimes the critical region is so tiny you can't see it. I just don't care for it. So I always use calculate. All right, so chi-square 2.1755. All right, we got 2.171. You say, wait a second. How come we got 2.171? They're getting 2.1755. Well, remember, that 9.78, the 10.22, I rounded all those, which means what? These are rounded and these are rounded. And then we rounded all this stuff again. Like, we double rounded already. So if you want to be more accurate with this, then we would just keep more decimal places here, and then we could get much closer to this. As a matter of fact, if I would have kept 4 decimal places here, there would have been 4 there, there would have been 8 here, and there would have been 8 there, and then there would have been 8 over here, and then we could have matched this and been a lot more accurate. But at the end of the day, like I said, we could be as accurate as we need to be. I'm not really concerned with that. I'm concerned with, do you understand how to get this value, number 1, out of the calculator, and of course by hand in the template. All right, so notice the 2.17 is there, and it's about approximately what we got. Okay, it's a little bit off. Bottom line is we're still comparing to 9.21, and clearly it fails to reject. We knew that answer already. All right, now it helped us. Now the p-value from the TI calculator, as you can see, is 0.337 approximately. All right, so the p-value, 0.337, obviously is less than alpha equals 0.01. So when that happens, so in other words, what's going on here? Well, the p-value is less than alpha. So therefore, we will fail to reject the null hypothesis. So this is just, remember, this p-value methodology right here. That is an alternate way to work a hypothesis test. And usually we use technology for that because remember it's an area outside of the critical value. All right, so this area, 0.337, which is the area from here to the right forever, is about 33% of the area under the chi-square distribution, is way bigger than the 1% alpha. So when the p-value is, oh, I got this backwards, I'm sorry. It should be greater than, right? Not less than. The p-value is greater than alpha. When that happens, fail to reject the null hypothesis. When the p-value is less than alpha, we would reject. All right, so as you can see, using the calculator really speeds the process up. So if we use the calculator, we'll get these expected results right away. Now you may be wondering, where are the expected results? I didn't see them. Well, that's actually because, remember, we told the calculator to put them in matrix B. In other words, if I go second, let me clear this out first. Second matrix. Now notice B is also set to be 2 by 3. So let's see, let's go down, and I'm going to hit enter. Matrix B, hit enter one more time. I'll get that. 9.7826. There's that 9.78 right there. 10.21. There it is, 10.22, because we rounded, right? Move over. 16.63, 17.36. There are those numbers. In other words, the calculator calculated all of these expected frequencies and popped them into a matrix. And you tell the calculator what matrix to put them in. So when you go to stat and move over to tests and go to the bottom here and get into this menu, to be honest with you, I never change these. I just leave them as A and B. I always put my matrix in A and let it dump the expected results in B. And this way I could call them whenever I want, and I always use the calculate feature. So out of this, when we did this, remember, we got the testing statistic, which we could use to do the test, or we got the p-value. The p-value, obviously, is bigger than any alpha you would ever dream up. So remember, we don't ever test anywhere lower than 5%. So we go 5% and 1%. A 10% alpha, and nowadays is unheard of. No one uses it anymore. It's not really considered to be statistically significant. So once you have the p-value, you could use the p-value methodology to do your hypothesis test. Remember the p-value methodology. If your p-value is bigger than alpha, fail to reject the null hypothesis. If your p-value is smaller than alpha, reject the null hypothesis. So this one here obviously is a lot bigger. All right, so hopefully this helps you out. If you have any questions, send me an email. Thanks.